If you watched our last video, you saw how Webb pushed past the edges of what we believed the cosmos could be, uncovering galaxies that shouldn't exist so early, so large, and so mature. But what you're about to see now takes that shock to a whole new level. Because this time, Webb didn't just find something bigger than expected, it found something that shouldn't exist at all. When the first stream of data rolled in from Webb's Deep Field Survey this month, it felt like any other day in the control room. Just routine follow-ups on a faint, distant galaxy that had been logged months before. No alarms, no raised eyebrows. Then, someone ran the spectral scan. The mood shifted instantly. Chatter faded. Chairs scraped closer. Faces leaned toward glowing screens. The numbers on the display didn't line up with anything in the archives. They were too clean, too intense, too tightly packed for a galaxy that small and that young. And right at the heart of the signal was something no one expected to find so early in cosmic history: the unmistakable mark of a supermassive black hole, weighing in at around 400 million times the mass of our Sun. For a few seconds, the room went completely still. Not because the scientists doubted what they were seeing, but because they didn't. They knew exactly what it meant. This wasn't a blazing quasar screaming across the universe in ultraviolet light. It wasn't a ravenous cosmic monster tearing through clouds of gas. It was something far more unsettling. A silent, fully formed gravitational giant, already grown, already settled, in a universe that was barely out of its infancy. According to the cosmic clock, the light they were seeing had left its source when the universe was only about 500 million years old. By every model on the books, a black hole this massive simply shouldn't exist yet. And that was the problem. Word spread fast. Internal messages bounced between NASA teams, then leapt to partner institutes in Europe and Asia. The same phrase kept appearing in inboxes: "This is too big for the timeline." The early universe was supposed to be messy, clumpy, slow. Tiny proto-galaxies forming, first stars flickering out, matter gradually pulling itself together over eons. And yet, in this small, unremarkable-looking speck of a galaxy, Webb had uncovered evidence of an engine that should have taken billions of years to build. But there it was, complete, quiet, waiting. To understand why this shook everyone, you have to know how black holes usually grow. Most start as the remnants of dead stars, just a few dozen times the mass of the Sun. From there, they slowly merge with others or sip gas from their surroundings. Even under perfect conditions, it can take billions of years to reach a few million solar masses. This one wasn't a few million, it was edging toward 500 million. So the question hung in the air, unspoken but unavoidable. How? When Webb zoomed in further, the scene only got stranger. The galaxy around the black hole looked calm, almost too calm. It was small, faint, tightly packed. No signs of a wild starburst, no warped shapes from a recent cosmic collision, and most surprising of all, it wasn't bright. A black hole this massive, if it were feeding, should light up its surroundings like a beacon, outshining the entire galaxy. But this one barely whispered. Its presence showed up only through the subtle tug of gravity on nearby stars and faint shifts in their motion. There was only one explanation. It wasn't feeding, it was sleeping. And in some ways, that was even more disturbing. Active black holes announce themselves. They flare, they blaze, they shoot out jets and show up clearly in surveys. Dormant ones hide. They swallow light instead of throwing it back into space. Finding one this enormous, more than 13 billion light-years away, requires a level of sensitivity only Webb can deliver. Once the initial shock wore off, the real work began. Teams started tearing into the question of how something like this could form so fast. One idea was direct collapse, where a massive cloud of primordial gas falls straight into a black hole without ever becoming stars. But even those theoretical giants top out at maybe 1 million solar masses, not hundreds of millions. Another theory pointed to dense clusters of massive stars collapsing together, but simulations hit the same wall every time. Radiation pushes gas away. Gravity can't pull fast enough. The universe, quite simply, doesn't move quickly enough to build something this big, this early. And yet, here it was. Harvard astrophysicist Dr. Priya Das put it bluntly in a briefing. We're not looking at an error, we're looking at a formation pathway that shouldn't exist. Others urged caution. Maybe the black hole wasn't truly dormant. Maybe it had once fed violently, then gone quiet. Maybe Webb had just caught it during a rare moment of calm. But even that idea raised more questions than it answered. To go silent, a black hole has to first drain or blow away the gas around it. That means an entire galaxy's worth of material would have had to spiral inward beforehand. And that takes time. Time the young universe simply didn't have. With every new measurement, the gap between what the data showed and what theory allowed grew wider. The accretion disk barely glimmered. The star's positions bent in dramatic arcs, tracing the pull of something overwhelmingly heavy at the center. The core of the system behaved like a single, colossal point in space. Test after test came back the same. The black hole wasn't a fluke. It was real. Some scientists floated the idea of a cosmic head start. Maybe parts of the early universe were denser than expected, letting matter crash together at incredible speed. Others pointed toward stranger possibilities, like unusual behavior from dark matter. What if, in the universe's infancy, dark matter halos collapsed faster than our models predict, dragging gas into deep gravitational pits before normal physics could slow the process down? There were even hushed conversations about a bold idea. What if the black hole formed first and the galaxy grew around it? It sounds wild, but with every new Webb discovery bending expectations, that once far-fetched scenario started to feel less impossible. Then came an even more radical thought, from researchers studying the cosmic microwave background, the faint afterglow of the Big Bang itself. A few teams suggested that some black holes might have formed almost immediately after the universe was born, in its very first moments. These primordial black holes have long lived in the realm of theory, but the concept is simple. In a universe expanding at blistering speed, tiny pockets of matter might collapse faster than our equations allow, creating massive black holes almost right out of the gate. For years, those ideas stayed mostly on paper. Then, Webb's data gave them a pulse. As the findings spread, NASA asked observatories in Europe and Japan to double-check everything. The verdict came back clear and consistent. This object fit the profile of a massive, dormant black hole. That's when the reporters started calling. Why wasn't it feeding? Why was it so enormous? Why did it exist so early? But inside the science teams, a deeper question took hold. What does this do to our entire timeline of the universe? If one silent, 400 million solar mass black hole could exist this early, maybe it wasn't alone. Maybe whole populations of black holes formed before galaxies had time to fully grow. What if we've had it backward all along? Instead of galaxies giving birth to supermassive black holes, maybe black holes were the architects, shaping, steering, and accelerating the growth of galaxies around them. Some theories have hinted at this for years, suggesting black holes as seeds around which galaxies condense. But even in those models, the seeds are tiny and take billions of years to become giants. Webb's discovery was more like stumbling into a forest of seedlings and finding a fully grown tree standing among them. As these ideas bounced around conference rooms and late-night calls, the mood at NASA shifted. This wasn't just another distant galaxy on a chart. It was a direct challenge to the opening chapters of cosmology. What else did the universe manage to build in its earliest moments? What else formed faster than we thought possible? Behind the scenes, scientists went into overdrive. They ran simulations with different chemical mixes, tweaked gas densities, adjusted temperature models, and reshaped the distribution of dark matter in their equations. Nothing could naturally produce a quiet giant this massive, this early, unless something truly exotic was at work. Still, the data refused to budge. The gravitational pull was undeniable. Even the most conservative estimates put the mass at a staggering level. And as Webb kept collecting more spectra, another detail emerged. The stars around the black hole weren't moving randomly. They weren't wild or chaotic. They were circling in smooth, orderly paths, like the kind you see in mature, settled galaxies. The heart of this galaxy was already calm, already organized, and that raised a question that drifted beyond equations and into something more philosophical. What does it mean when the universe outruns our timeline? When things form faster than our laws allow? When a giant lies sleeping in the cosmic dawn? For the public, it might sound simple. Webb finds another ancient black hole. But for scientists, it's something else entirely. It's a signpost, a hint that the early universe was more intense, more efficient, and more aggressive than our models ever predicted. And maybe the most unsettling detail of all isn't how powerful this black hole is, it's how mature it seems. Something this enormous shouldn't have had time to settle down, yet there it was, quiet, ancient, impossibly massive. As teams prepare the next round of Webb's observations, the stakes are clear. If more silent giants appear at similar distances, cosmology won't collapse, it will expand. The timeline won't break, it will be rewritten. A universe that did more, faster in its first moments than we ever imagined. Whatever Webb uncovers next, one thing is certain. It's forcing the cosmos to give up secrets it's held since the very beginning. And this silent 400 million solar mass giant? It's only the opening chapter.